You're like, where you guys staying though? I know you're stuck with me.
Yeah.
I don't know. I just
Do you have any like hobbies?
nothing. I just like that.
Do you just do you have pictures?
I'm kidding.
What do you do?
Teaches a bicycle.
Yeah, what do you
I do. I teach spin, you know, like the indoor cycle
Really?
class.
I used to do fun. Where do you teach it? Like,
Yeah, I teach at Evolution in Indiana.
what? That's like really cool.
And then I also teach at the bike lane production company.
Wow. That's so cool. Yeah, let's go.
You ever teach us math, please?
I do not teach at math crazy.
Math, please.
Basketball.
What? Play volleyball, basketball, the track.
Wow. That's awesome.
And then I did work at Chipotle.
Yeah.
Ah, that would be cool.
And then I do track in college.
What's your favorite hobby?
Basketball's fun. It's definitely what I was the best at, and that's what I went to college for.
Oh,
But then I
really?
Division II school in Nebraska, so.
Did you pay for all 4 years?
But I did track. I switched to track and I did track the whole time.
Sorry, I don't mean to like read you here. I'm just kind of.
Yeah, what else do you want to know? You guys didn't get like the day one getting to know me.
Yeah.
So, you know, if you remember all these.
We used to meet.
I do.
Do you have any like secret talents?
Do you have a ring in college? Like for.
I was all conference in practice.
Wow.
And we were state champions in volleyball.
That's awesome.
I used to coach track. Yeah, not here. I did, we're in Tottenham.
She passes us all the coach practice. Were you long distance?
I threw the shot put discus and javelin.
Oh, so the steel part.
That was like he's like waiting.
Yeah, Chad's the other part.
That's not that place. I'm super happy. Do you have any pets? Yeah, do you have any pets?
Dog.
And a goldfish.
Not a goldfish. My son really wants a fish. He wants a turtle, he wants a fish, and he really wants a frog.
Dude, turtles are cool.
I have a 4-year-old, so
So he wants all the animals.
he would like one.
You should get like I
Or the dog, that's enough for now.
Give him $50 to spend on what you want. No,
In the 4-year-old.
Just send him off on his own
By the
shop.
time he's 8, he's gonna be asking for like $1,000.
$50 is $1,000. Not even
$10.
Under
Like $10.
Sure, and so like their mom would be like $5,000. But you like $100, and I was like, what? I was scared to get that. I went to the school and all these like he's like classic sword is like $50. And I'm like, why is everything so expensive now? Inflation's horrible. So like the sets are like $200 if they're like 1,000 pieces.
What's your favorite? Do not live in the expensive toy. Cheap and go play outside. My favorite food?
Yeah.
I like all soul food. That's really hard.
But if you had to live off of one food,
Seafood is the one that I'll eat it, but
live off of
like one type or like place to eat at.
Chipotle.
There's a place in Birmingham called Charcoal Kebab. One of my favorite places. I got a gift card from a student last year for that.
I go there all the time.
No, it's like way too expensive. Why not? That's why I need to get it. Okay, so how about I stop our recording and start it over? 4.5 minutes of. All right, we'll continue. Okay, guys, so let's get through some of lesson 5. We'll see how far we get. What time you told me, Natalie? When you have to leave? 1:15. Jack. 1:40. Jack, did you tell me you have to leave early?
Yeah,
1:20. 1:20. Okay. Any other time?
Don't all leave at the same
Yeah.
time. Wait, so I'm doing 120.
You'll just have time to work on stuff.
He's
I
good.
promise you. Okay.
Thomas is football.
Oh, you guys do.
Okay, got that all sorted out. All right, guys, so we have a business here. They're investing $5,000 in a new product, so that's like their initial startup cost. And then it costs them 50 cents per unit to produce. I'm asking you now to find the average cost per unit. So guys, if you think about it, you have that $5,000 initial cost. If I only make 2 units, that only gets split over 2 units, right? So it would be really expensive. If I made 100 units, that average would come down. Do you follow me here? Does this make sense to you? Okay. So let's write an equation for this. It is not linear. Not linear. So our cost equation is going to be your $5,000 plus 0.5x because it's 50 cents for each unit. So the cost equation is linear, but the average of the cost is not linear. How do you think I would do the average of this then? For average cost per unit. How do you find an average?
Add them all up and then divide by the number.
Okay, so what in that equation represents the number of units? X, right? So we're going to be dividing by x. So it's this 5,000 plus 0.5x divided by x. What? They will not. Yeah, because you can't take it out of the 5,000. So we'll just leave it like this. Okay? And then this part A said, what's the average cost when there's 1,000 units produced? So what would I do with that 1,000? Plug it into that, yeah. So when x equals 1,000, use your calculators, guys. What do we get? Average cost per unit equals 5.5, so $5.50, okay? Okay, so then part B is just asking us to find the average cost when 10,000 units are produced. So what do you think? The average cost per unit, is it going to be more or less? Less, right? Because you're spreading it out over 10,000 units now. So what do we get when x equals 10,000? What'd you get, guys? $1, yeah. Okay. What about when we make 100,000 units? We can have it, so you can set it on there and I'll add it to. Thanks, appreciate it. I don't, that's all I have for my last class. That's it. He forgot to add 90 and not 60.
Oh no, you should tell me today because I made
I'm so
you have
sorry. I have a lot of it.
And it's whole punch.
They can just share.
Yeah.
See, I have
It's cold
fun.
punch.
And it's whole punch. That's the highlight. right, guys, what are we getting for this one? Okay, so 55. Okay,
Wait, would you do dollar sign or can you just do 55 cents?
that would be fine. Don't do both. Okay. And don't do like 0.55 cents because that's
Yeah,
less than a penny.
Yeah.
Okay.
I'll let you do that. Yeah. Cut it.
When I ask about fractions, sometimes you think we're back in elementary school. The panic just comes in. I say common denominator, and it's just.
When I was in 5th grade, our teacher told us the song about pi, how like fractions were basically pi. It's like
Yeah.
fractions like it's one is one.
Yeah, I would teach them pizza.
What was this thing Mr. Clark? We should put it on this.
Maybe not today.
So great.
All right, so then part D, find the average cost per unit if production never stops. So we've been increasing the number of units. I'm talking about now if we produced an infinite number. So I'm asking you the limit as x approaches infinity, okay, of our average equation here. So what we have to think about the horizontal asymptote. So yes, this is something from pre-calc, okay? Horizontal asymptote. But it'll be okay, guys, I promise. Are we crying already? I promise I'll make it better, okay? All right, so if we think about our little equation here, 5,000 plus 0.5x over x. Horizontal asymptotes were that whole top-heavy, bottom-heavy equal stuff, okay? What we were looking at there was the degree in the numerator and the degree in the denominator. So if I look at those are the two pieces I need to look at, right? I don't care about the 5,000. If I'm plugging infinity into this, 5,000 doesn't make a difference, right? So since the degree of these are equal, both have a degree of 1 on the variable, all I have to do is divide the coefficients. So what is 0.5 divided by 1? 0.5. So the limit of my average equation here is just equal to 0.5. So that means the average cost per unit is getting really close to 50 cents per unit. It'll never equal that, and it'll never go below that. Which makes sense since it costs you 50 cents per unit to make them. You could never get below that, right? Okay? And it's all graphed for you up here. I don't know if you guys looked at the graph. This is the graph of what we were doing. This is just the simplified equation, but it's the same one. The cost per unit is really high at the beginning because you haven't made very many units, and then it decreases, and it levels out just above that 50 cents per unit. Does it logically make sense to you guys? Okay. Any questions? Okay, so let's look at another one. All right, read this. I'll give you a second to read about salt water. Okay, part A is asking you about the volume of the water. And guys, I know you haven't been putting your phones up, and most of you are doing fine, but make sure you're paying attention. So volume. Does the amount of salt in the water have any impact on the actual volume of water that's going in this tank? No, it's just telling me how salty the water is, okay? The volume has to do with the 70 gallons that it started with, and then how much water is coming in there per minute. Okay? So let's write an equation here, V of T, volume over time. What do you think? What would you write for your equation?
32 plus 70.
Perfect, 3T plus 70. It's linear. You started with 70 gallons, you're increasing that by 3 gallons every minute. Okay, so T equals 4. We good there? Okay. So then part B is where we actually care about the amount of salt in the tank. So A of T equals, and this is a little tricky. Yes, just 12 T. Perfect. Alright, so the amount of salt initially in our tank is 0, right? Because it was just pure water to begin with. And then we're putting in 4 grams of salt per every gallon. But how many gallons are going in every minute? 3, so that's why it's 12. Okay, so you're actually putting in 12 grams of salt every minute. Alright, then part C, find the concentration of salt. So, this is where we have to divide the salt by how much water is in there, because that tells us how concentrated the salt is in the water. And this helps you. It says in grams per gallon. Grams over gallons. So that's salt over, like, volume of water, right? So we're going to write our equation just as 12T over 3T plus 70. Does that make sense? We're taking the total salt divided by the total water to get the concentration of salt water. All right, we're going to graph the concentration and then find the limit as time approaches infinity. So, I want you to try to make a sketch. You know where to begin, or are we all a little scared? You got it? Some are scared, some got it. I'll give you a second. You what? Oh, stop. Alright guys, how's your graph looking? Alright, let me help you out with the X and Y axis labels at least. What's almost always on our X-axis?
Time.
So time, or you could say number of minutes. And then the concentration, what we're looking at is the grams of salt per gallon.
It's like one of those apps, like remember the World Cup?
What are those called? Something with a
Yeah.
They have a name. Someone remember the name. Thank you. I knew it was a blue or something. It is. All right, guys, so let's look at this. We're looking at the limits. As t approaches infinity. So when we started, it's going to start at 0, 0, right? Because when our time was 0, we didn't have any salt in the water. Okay? And then it increases, but it's going to level out. What do you think it's going to level out at?
4.
It does level out as 4. The limit is 4. That's where your horizontal asymptote is. In the true life meaning of this answer is an interesting way to word that. Water can only hold so much salt, right? You guys done experiments in science classes before where you ever like stirred up water with salt in it?
All the time.
Okay, you get to a point and you can't add more salt. So yes,
It just goes through that.
it won't dissolve. That's all this is talking about. Okay? All right, real quick, I want to make sure we get through reviewing horizontal asymptotes, and then that's about all we're going to do today. So whoever has to leave at 15 after will be closed. Because you're going to have your quiz next time. So we got to practice some of this stuff. All right, guys, so horizontal asymptotes. What?
We're not doing all of them?
We're not.
Nice. Should we do all of them?
I'll only put on your quiz the stuff that we've done. But this is on your quiz. All right, so if it is bottom heavy, that's talking about the degree of the denominator is greater than the degree of the numerator. I know I'm abbreviating a lot here, but you guys, this is vaguely familiar to you, right?
Yes.
Degree, yes, it's big. So let me give you an example. So let's say our function f of x is equal to 3x squared plus 3x over 4x cubed. That term and that term are all that we care about, right? Degree on the denominator is bigger. What that means is that the limit of f of x as x approaches, in this case, either positive or negative infinity, will be 0. So bottom heavy, those are the easiest ones because it's just going to be 0 no matter what. Those are those graphs that look like this and like that. Okay? As you go to either end, your graph is approaching the x-axis. All right. Balanced, that's the same as equal. Okay? Degree of numerator equals degree of the denominator. Let's do one of those. Let's say we've got f of x equals 6 minus 3x cubed over 2x cubed plus 5. So, we only care about two things. I care about the negative 3x cubed over the 2x cubed. When those degrees are equal, all you're doing is dividing the coefficients. So what would my answer be here for the limit? Yep, negative 3 max. Okay with that. So top heavy, that means the degree of the numerator greater than the degree denominator. So let's say we have f of x equals 3x to the fourth minus 2 over 4 plus x cubed. Alright, so let's look at what we care about here. Are you guys with me or am I going too fast? Good, okay. So I've got 3x to the fourth over x cubed. You guys see how the numerator's, the degree is bigger, right? What you're really doing is taking that fraction and you're just reducing it. So, you guys see how what I'd be left with is 3x? Okay. What does the graph of 3x look like? It's just a line, right? I'm not talking perfect graph here, just general shape, like it's something like that, right? So we are going to do two limit statements for this. We're going to do one as x approaches positive infinity. So what do you think? As I go to positive infinity, where is my graph going? What? I'm sorry. Yeah, positive infinity. So that's my limit for that one.
Wait, that's 3 or x2?
This is a 3. Okay. And then the limit of our function as x goes to negative infinity. So as you go way far to the left on your graph, where does it go? Negative infinity. So the top heavy ones are the trickiest. You need to make a picture for those, okay? All right, so let's do a few examples with these. I want you guys to try these 4 and then we'll go through them. Let's see what you remember. You guys really good. You're okay. Like this is it.
Yeah.
Okay, good. Thomas, I need to take your phone.
No. That's not.
Did you reply? I'm in the middle of a flight count. Leave me alone.
I was gonna back off and let you get right.
That's it.
Well, it's a lot of people. Then she yells at me for texting in class. Like, you texted me first. My mom would have a meeting all at work and school. That's really helpful. But I didn't really get any other time, like, what do you do? I don't know whether to speak of one half.
These 4 should not take you very long. Yep.
Yeah. We go to the parks, and then they're not done. Like now, that's what I think. That's okay. Now we should see what. We don't think we should. That is where you still take the high school. You still simplify it. And then what's left? Let's shape that graph. Is it perfect? So reduce the first, so you'd be left with. What is like? No, so these is okay to have infinity as an answer, because x is approaching infinity. The other one's x is approaching infinity. So guys, yeah, that's a good question. These you won't have does not exist. It's okay to have infinity as an answer.
How do we know the difference between these ones?
So what is x approaching these?
Okay, so the X is approaching.
Then you can count.
And then four.
Yeah. -3.
Yeah. So number one, what'd you guys get?
1/2.
Yeah. Number two. Number three.
-3.
-3. Is everybody okay with it being negative? Okay. And then number four, guys, this is where you look at that over that, which simplifies to 4x. So you think about that graph. So as x approaches infinity, what do we get? Okay.
I don't understand like why you just did the one drive for that.
For number
Or
four.
for that person, yeah.
Okay. It was top heavy, right?
Oh, so you do it always.
Yeah, so that's why I was like these simple. This one is a bigger picture. Like the top heavy
Oh,
ones
so
you
you're
gotta think
talking
about. Yep. Alright, so we're okay?
Yeah.
Let's try a couple more. Try 5, 6, and 7. Stop there. Easiest to yes. Nothing to do with it, right?
What if it was like x to 4? This is to 10 x.
Oh, then you
Then you gotta think.
go back to plugging in that value if you can.
Oh.
to each other, see if you agree.
I mean, for seven.
For 7?
I thought the duration was for 1.
Me too. And there's another way to think about it. I'll show you.
It's asking for what is equation. Oh, yeah, okay. And then split 0. 5 0.
Alright guys, let's go through these. What'd you get for 5? 0. We like those, right? Bottom heavy is easiest, just write 0. Okay. 6. Negative infinity. Okay, that's top heavy. When you simplify it, it's negative x, which is the graph. Like this. Yes, are we drawing pictures? Okay. Alright, 7. 7's a little different. There's 2 ways you can think about doing it. First is to find a common denominator. So this would become 5x squared minus 2 all over x squared. Okay? Because now is it top heavy, bottom heavy, or equal? Equal, so what is the limit going to be then? 5. Alright? The other way you can think about it, if you leave it 5 minus 2 over x squared, x is approaching infinity, right? That's a really big number. If I do 2 over something huge, what is this term getting really close to? 0, right? 2 over a really big number, a really small number total. So then all you're left with is the 5. I think this way is just more in line with what we've been doing, but you can think about it either way. Okay? Yeah? We're there? Okay, we're doing one more together and then we're done. Alright, so 8, you're given this equation, and it says, can it cross its horizontal asymptote? And if so, where does that happen? So first, what is the horizontal asymptote for this graph? What? I'm sorry. No, I just didn't hear you. Okay. 2, right?
Yeah.
Remember horizontal asymptote, that's the same as the limit as x approaches infinity. It's what it approaches. Okay, so what we're trying to figure out is, can this equation equal 2? So 2 equals 2x squared minus 5x plus 1 over x squared minus 9. I want to know if there's a place where that happens. How do I go about solving that? What? You don't have to factor. We don't have anything to plug in yet. We're solving for x.
Can you give over the?
Yeah, is that what we're No? Well, we won't go down that road. Okay. Yeah, I don't really want that fraction over there, so I'm going to multiply both sides by this x squared minus 9. Then it's gone from there. And I can distribute, so I've got 2x squared minus 18 equals 2x squared minus 5x plus 1. Okay, so then I go to solve. What's going to happen with my 2x squareds, no matter which side I move it to? Yeah, those are gone. And then, so I'll do minus 1. So I have negative 19 equals negative 5x. So, what? Why do they? Or, oh, you're just saying they do. Okay. So, yes. At making this up. Do you guys remember your rational functions project from pre-calc last year? Yes. No? What?
Equations.
Yeah, so you had to graph them like, I don't know, in my class at least, each person had to do their own, and then you had the bigger one that you were supposed to make like pretty, yeah, okay. So remember how you had some weird ones where you might have like a vertical asymptote here and a horizontal one here, but your graph might do something like that in the middle. Remember, it's okay to cross a horizontal asymptote. It tells you about the ends of your graph, not necessarily the middle. So that's why that one works out that you can't cross the horizontal asymptote. Okay. Stop there. Homework.